All right, so continuing, so looking at this set of data that I've added in, so kind of cases, US, Spain, and Italy. I'm just going to change the title up here so we can see it a little bit better. So, coronavirus cases, US, Spain, and Italy. And again, we can kind of lets us see these different slopes here. So, one of the things that we can do when we're kind of modeling these is I'll kind of move this over here. And so, what I've created to the right of this is a cell here, and you see that it does a calculation for me, and it takes the exponent of days times some number up here, and it multiplies it basically takes the exponent of that. So it's like y, the coronavirus cases, is equal to e, which is Euler's number, like 2.8, raised to this number times this number. So I've got three different scenarios here. And then what I do is I can click on here, and then I come over here to this, kind of make a crosshair. I can drag it down, and it just kind of moves that formula all the way throughout. Now, one thing I want to do is you can kind of look at this and see how we can work our way through that. And so, point two, you see like the numbers are a lot lower. Point here, I got 0.286. And so, what we can do is we can add in. We can add those columns into our graph. So we come over here and we can add those in. We edit, come in, we want to add some data. And so instead of D42, I'll just make this a G to include those others. And so now looking back here, now kind of just dragging our graph over, we have kind of three different projections in terms of three different versions. And you can see these numbers here representing these different exponential curves. So what we can do with those series, I can come in here and I can look at these and I want to say, all right, 0.2, I'm going to make a dashed line, 0.286, going to make a dashed line, and 0.3, make that dashed line. And so all that does is it just shows kind of these three different bands for what that exponential growth could look like. And so when we look at this, it's a little bit hard to see. And so what I'm going to do is I'm going to take Italy out. And so I'm going to go to setup, and I'm going to come over here and Italy. I'm going to remove. So now I've just got US, Spain, and then these two bands here. And what I can do is so these are the kind of the numbers that I have up here. And what you'll see that I've done is I've kind of messed around with this middle number, try and get the column here to match up with what we saw for the US. And not perfect, but you see that this number 0.286 gives us a reasonable fit for it. And so when we look at this, so right now it's this kind of the green dashed line and seeing how well it lines up with the blue line. And again, so on this normal version, it's a little hard to see those two lines sitting on top of each other. But if we go back to vertical axis, go back to log scale, we can see that the green dash and the blue are sitting on top of each other pretty well. And so what that just shows is that this model of exponential growth, 0.286, seems to be a good fit for what we've been observing in the US. Now, one of the things that allows us to do is we can then extrapolate, kind of add, kind of try and project beyond what our graph will show. And the extrapolation for coronavirus cases in the US is just under 93,000 for tomorrow. So tomorrow we'll check back in and kind of see where these numbers are, and it will kind of give us a chance to follow back up on how good extrapolating may or may not be. So we'll wrap up with that for today.